Welcome, everyone. Today we are exploring the strategic synthesis, shift left and shift right. In the landscape of modern software development, it is no longer enough to choose between early prevention and late-stage resilience. Instead, we must unify these two approaches within our software development lifecycle. As depicted by the infinity loop, shift left represents our commitment to proactive prevention, integrating security and quality at the very beginning of the development process. Conversely, shift right focuses on real-world resilience, leveraging monitoring and observability in production to ensure our systems can withstand and adapt to unforeseen challenges. Together, these strategies create a continuous, virtuous cycle of improvement, ensuring that we deliver software that is not only high quality, but also incredibly robust and dependable.
The exponential cost of quality highlights a critical reality in software development. The later a defect is discovered, the more expensive it becomes to fix. Starting at the design phase, resolving an issue costs roughly $100. However, as we move through the software development lifecycle, this cost multiplies tenfold at every major stage. Finding that same bug during coding increases the cost to $1,000. By the integration phase, it reaches $10,000. Once a product hits production, the cost of remediation can exceed $100,000, representing a staggering 1,000-fold increase from the initial design phase. Beyond the direct financial costs of development, the impact on user experience is even more severe. 68% of users will abandon an app after experiencing just 2 glitches, and 88% are less likely to return at all after a poor experience. Perhaps most critically for business revenue, 75% of cart abandonment is attributed directly to checkout bugs. These statistics underscore that quality is not just a technical metric, but a fundamental pillar of user retention and business profitability. Addressing quality early is not just efficient, it is essential for success in a competitive market.
The transition from linear handoffs to continuous loops represents a fundamental evolution in software development methodology. In the legacy waterfall model, shown at the top, the process is strictly sequential. Work moves from requirements to development, but often encounters a wall of confusion before reaching the testing and deployment phases. This siloed approach frequently results in communication gaps, delayed feedback, and significant friction during the final stages of a project. Conversely, the modern DevOps paradigm utilizes an infinity loop to illustrate a culture of continuous integration and delivery. Rather than isolated handoffs, this model creates an interconnected cycle where planning, coding, building, and testing are seamlessly integrated with release, deployment, operations, and monitoring. By breaking down the traditional barriers between teams, this approach fosters constant feedback and allows for rapid, high-quality releases. This shift from a linear path to a continuous loop is essential for achieving the agility and operational excellence required in today's fast-paced digital landscape. Shift left, engineering for prevention, represents a fundamental shift in our development philosophy. By definition, this approach involves moving testing, security, and quality evaluation to the earliest phases of the development lifecycle. Instead of waiting for later stages, we verify requirements and code before they are ever merged into the main branch. This strategy offers 3 critical advantages. First, it enables early bug detection, allowing us to catch logic errors when they are at their absolute cheapest and easiest to resolve. Second, it provides fast feedback, effectively reducing the feedback loop from a scale of weeks down to mere minutes. Third, it leads to reduced technical debt by enforcing strict code cleanliness and standards at the individual commit level. Ultimately, our objective is proactive rather than reactive. As emphasized on the slide, the goal is preventing defects from entering the codebase in the first place, rather than finding and fixing them after the fact. This ensures a more stable, secure, and efficient engineering process from the very beginning.
The Shift Left toolkit comprises 4 essential pillars designed to embed quality and security early in the software development lifecycle. First, we utilize static application security testing, or SAST, which analyzes source code at rest to identify potential vulnerabilities without the need for execution. Next, software composition analysis, or SCA, allows us to scan third-party and open-source libraries for known CVEs, ensuring the integrity of our dependencies. We also emphasize test-driven development, or TDD, where tests are written before the actual code to guarantee testability and robustness by design. Finally, through CI/CD integration, we establish automated quality gates that proactively block builds if any tests fail, ensuring that only high-quality, secure code reaches production.
The simulation gap represents the fundamental disconnect between our testing environments and the reality of a live system. In a pre-production environment, everything is controlled and orderly, represented here by the simple structured cube. We rely on simulated traffic, mocked APIs, and predicted behaviors to ensure our code functions within a safe, sterile bubble. However, as we transition into real-world production, this simplicity evaporates. We are suddenly confronted with a complex, chaotic web of interdependencies. We face the harsh realities of network latency, unpredictable third-party failures, and massive scale. These factors introduce unknown unknowns, issues that simply cannot be replicated or predicted in a staging environment. Ultimately, scanning a static image or testing in a vacuum cannot provide the rich, actionable insights that come from observing an application as it truly lives and breathes in production.
Shift Right is about ensuring real-world resilience by extending testing and quality assurance practices into the production environment. This allows us to validate performance under actual usage conditions, moving beyond the limitations of pre-production environments. We focus on 3 core areas: resilience, which verifies the system's ability to recover from failures; user experience, which involves monitoring actual user journeys in real time; and reliability, where we test for performance under peak loads. This approach acknowledges a fundamental truth in software engineering: production is the ultimate reality test. The Shift Right toolkit comprises essential strategies for ensuring system reliability and performance within production environments. Starting with canary deployments, we roll out updates to a controlled subset of users, generally between 1% and 5%. This allows us to monitor stability and gather real-world data before a full release, effectively mitigating the impact of potential bugs. Next are feature flags, a core component of dark launching. This technique involves deploying code with features hidden, which can then be toggled on for specific users. This provides a safe way to test new functionality and perform A/B testing without impacting the entire user base. Chaos engineering takes a proactive approach by intentionally injecting failures into the system. The goal is to test the platform's resilience and self-healing capabilities, ensuring it can withstand unexpected disruptions in a live environment. Lastly, observability provides the necessary visibility through metrics, logs, and traces. It moves beyond simple monitoring by helping us understand the why behind system behavior, allowing teams to diagnose and resolve complex production issues more effectively. To understand the core differences between these 2 strategies, we must examine their attributes across the software development lifecycle. Shift Left is fundamentally about prevention, focusing on defect prevention and code quality within pre-production or virtualized environments. This approach is designed to catch logic errors, syntax issues, and security vulnerabilities early, providing immediate feedback in a matter of seconds or minutes. In contrast, Shift Right focuses on resilience, prioritizing system stability and the actual user experience within the live production environment. This strategy is essential for identifying issues that only surface in the real world, such as performance bottlenecks, configuration drift, and complex Heisenberg bugs. Because these insights depend on live data and user behavior, the feedback speed is naturally delayed, often taking hours or days to materialize. Both approaches are necessary to ensure a high-quality, resilient product. The continuous feedback loop illustrates the critical synergy between development and operations, represented by an infinity symbol that denotes a seamless, ongoing process. On the left side of the cycle, the Shift Left approach focuses on integrating quality, security, and testing earlier in the development lifecycle. This proactive strategy is essential for reducing technical debt and the long-term maintenance tax that accumulates when issues are addressed too late. As we follow the top curve, we see that left protects right. High-quality code and rigorous early testing act as a foundational safeguard for the production environment. Conversely, on the right side, the Shift Right strategy involves continuous monitoring and testing in live production. This ensures that operational risks are minimized and user churn is reduced by identifying performance gaps before they impact the broader customer base. The most vital part of this cycle is the intersection, context-aware prioritization.
Here, right informs left as real-world production data is fed back into the development phase. This allows teams to move away from theoretical roadmaps and instead use empirical evidence to prioritize development fixes that have the highest impact on the user experience. This continuous flow ensures that the development process remains agile, data-driven, and perfectly aligned with operational realities. By 2026, we anticipate a fundamental shift toward an AI-augmented lifecycle, where the traditional DevOps loop is significantly enhanced by automated intelligence. On the left, we see the emergence of AI auto-fix capabilities. Here, artificial intelligence does not just identify issues, it actively generates pull requests to resolve bugs automatically. A critical component of this is auto-triage, which is projected to filter out 90% of false positives, allowing engineering teams to focus exclusively on high-value innovation rather than maintenance noise. Moving to the right, we encounter agentic AI. This represents a more advanced stage of autonomy, where intelligent agents monitor systems in real time. These agents are designed to detect pattern drifts and initiate self-healing protocols for infrastructure without the need for manual human intervention. This creates a resilient, closed-loop environment that maintains its own health and stability. When we integrate these two pillars, we move toward a state of continuous, autonomous optimization. This evolution serves as the foundation for our 2030 prediction, the achievement of near self-driving operations. In this future state, the system manages the vast majority of its own maintenance and optimization cycles, representing the pinnacle of operational efficiency. Measuring success requires a comprehensive approach that balances development quality with operational excellence. We categorize our key performance indicators into 3 distinct areas: shift left, unified DORA, and shift right metrics. Shift left metrics prioritize quality early in the development cycle. Key indicators include the vulnerability escape rate, which we aim to keep below 5%, alongside code coverage and the build failure rate. By monitoring these, we ensure that stability and security are integrated into the product from the very beginning. In the center, unified DORA metrics provide a baseline for our delivery velocity. We specifically focus on deployment frequency and lead time for changes to measure how effectively we are moving code through the pipeline and into the hands of our users. Finally, shift right metrics offer insight into the health of our production environment and the actual user experience. We track the mean time to remediate to assess our responsiveness to incidents, utilize AppDex to quantify user satisfaction, and manage error budgets to align our deployment speed with necessary reliability. This holistic framework ensures that our speed never comes at the cost of quality or stability. Our implementation roadmap is structured into 3 strategic phases to ensure a robust and scalable deployment process. We begin with Phase 1, the foundation, which focuses on shifting left. During this phase, we adopt test-driven development and automated unit testing to build quality into the code from day one. Simultaneously, we integrate SAST and SCA into our CI pipeline to secure our software and manage third-party risks early in the development lifecycle. Phase 2, expansion, shifts our focus to the right and emphasizes operational readiness. We will implement feature flags to facilitate gradual rollouts and minimize release risk. Additionally, we will establish detailed observability through comprehensive traces and logs, providing the visibility needed to manage production environments effectively. The roadmap concludes with Phase 3, optimization, which represents the synthesis of our efforts. In this stage, we feed production metrics back into our test planning to ensure our testing strategy reflects actual user behavior. Finally, we will deploy AI agents for auto-remediation, closing the loop with intelligent automation that proactively maintains system health and performance. The speed of feedback has become the ultimate competitive advantage in our modern landscape. This advantage is not derived from the size of a team, but rather from the sophistication and efficiency of the feedback loops we establish. To maximize this, we look at 2 critical approaches: shifting left and shifting right. When we shift left, we focus on building with precision. This means integrating testing, quality assurance, and security earlier in the development process to identify and resolve issues at their source. By doing so, we minimize rework and ensure a more stable foundation. On the other side, shifting right allows us to learn from reality. This involves monitoring and gathering data directly from production environments to understand how our systems perform in the real world and how users actually interact with them. By balancing these 2 strategies, we create a continuous loop of learning and improvement. The goal is to move beyond mere execution and foster a culture where the speed of insight drives our path forward.
The analysis provided in this presentation is supported by data and frameworks from leading organizations across the technology sector. Regarding the cost of quality, we reference studies from Cloud QA and IBM. Our security and CI/CD insights are drawn from GitLab, Snipe, and Sonar, while observability and APM trends are based on reports from Dynatrace and New Relic. We have also incorporated the latest advancements in AI testing and automation from Virtuoso QA and TestTrigger, alongside cloud-native security benchmarks from Wiz and Aikido. The underlying methodology is informed by Relevance Lab and Codecraft. Crucially, this entire analysis is forward-looking, utilizing industry reports for the 2025 to 2026 period to ensure our strategic conclusions remain relevant in a rapidly evolving market.